This lesson deals with equivalent fractions. So before we get started, let's just talk about a couple of definitions. The first one being a fraction. I'm sure you've all seen fractions at some point. And just think about how you would define a fraction. Usually it's thought of as two numbers divided by itself, which is exactly what the definition is. A fraction is considered to be a quotient, which is the math term for division. So it is a quotient of either two numbers or two algebraic expressions. So, like I said, you've probably seen fractions before. I'm sure you have. Sometimes they're numbers, sometimes they have variables and other terms in there. In that case, they're algebraic expressions. Now let's talk about what it means for two fractions to be equivalent. And you've seen this before as well, you just might not have referred to it in this form, but two fractions are considered to be equivalent when the numerator and denominator of one fraction can be multiplied by the same non-zero factor to arrive at the second fraction. So usually what we think of is when we're reducing fractions. We start off with one fraction and then we reduce it to get what's called an equivalent fraction. Another thing to keep in mind with regards to these is the negative sign. Many times it's necessary to use a fraction in one of its equivalent forms. When we're adding and subtracting, a lot of times we need to find that common denominator. In order to add or subtract them, we can only add when we've got a common denominator. And sometimes we need to pay attention to the sign. So sometimes we've got a negative sign out front, and that means the whole fraction is negative. But we could also move that negative sign up to the top and make the numerator the negative part. Still makes it a negative fraction, but in this case the numerator took that. Or we could also instead put it in the denominator if that's necessary to get an equivalent fraction or to get a common denominator. The other thing that we need to keep in mind is what we refer to as lowest terms, and so this is what I was referring to when I said we reduce fractions. A fraction is considered to be in lowest terms when its numerator and denominator have no common factors other than 1, because everything has a common factor of 1. It's our unit. So in this case, when we talk about lowest terms, we're saying, okay, if the numerator and denominator have a common factor, we can factor that out and divide by it, and anytime you divide a number by itself, we end up with 1. So if we look at the following example, we want to reduce this fraction to lowest terms. Now we say, okay, what do 27 and 57 have in common? Take a second to think about this. And they actually have in common 3. So we say, okay, we got 27 divided by 3 would leave us with 9. 57 divided by 3 would leave us with 19. So if we reduce this, we end up with a fraction of 9/19. Now some people also go through and cross off the x values. I find this to end up looking a little bit messy, so I try not to do it. But in this case, we've got x squared and x to the 5th. The x to the 5th is in the denominator, so we'll keep the term down here. 5 minus 2 is 3, and this is going back to what we talked about in section 1.8 and 1.9. If we look at the y terms, Then we have y to the 7th, again, is the higher exponent term, so we're going to keep the term in the denominator. 7 minus 3 is 4, and then z to the 4th doesn't have anything that it can simplify with, so it just stays up top. So this is the simplified version, or the fraction in lowest terms. We can also do this when we've got common factors, so larger terms, given that they are in parentheses. We cannot cancel, so if you look at example 41, we cannot cancel, for instance, x squared and x squared because these terms are not factored. We can only cancel when we have common factors. And if you look at example 40, first we can say, okay, 12 divided by 3 is 4. And then you can look at the common factors. These are multiplicative terms, so we can divide them. Multiplication and division, again, are inverse operations, so that is why we can so-called cancel when we're looking at large fractions. So 3x minus 4, 3x minus 4. The term with the larger exponent is here in the denominator, so 5 minus 3. So we got 3x minus 4. Our exponent's 5 minus 3. We end up with squared. Also, if you look at the 2x plus 5, the larger exponent is in the denominator, so we have 2x plus 5, and in this case 3 minus 2 is 1, so we don't need to write an exponent. Just to make this look a little more symmetric, I'll move the 4 to be in the center. And we have simplified this one. We took care of both factored terms here, and we put them in the denominator because that's where the highest exponent was to begin with. If for some reason the terms aren't factored yet, or the expressions aren't factored yet, then we can just go through and factor them. So this is one of the reasons that we went through and reviewed factoring, was so that we could simplify these fractions. So if you look at this one, x squared plus 5x plus 4. Well, if we factor that, we know we've got x and x. What factors of 4 add to give us 5? That's pretty easy. 4 and 1. They're both going to be positive because our last term and our middle term are both positive. If you look at the denominator, we've got x and x, factors of -7 that are going to add to be -6. Again, not too hard. -7 and +1 will add to be -6. And then again, now we can simplify because we have factored. These are multiplied terms. So we can say x plus 1 divided by x plus 1 is 1. And we are left with x plus 4 over x minus 7. So if we had gone through and canceled those x squareds, we would not end up with the same answer, and we would not end up with the correct answer. So please never, 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 never try to cancel before you factor. If you've got a plus and minus and nothing is factored, like you see to start off here, you cannot cancel the x squared. The first thing you have to do is factor. You can only cancel those plus and minuses when they're in parentheses and they match another term in parentheses. So at this point, pause the video, see if you can try the next example. So for this example, you should see that the top one, we did a similar example before we were factoring. It is a perfect square trinomial, so it is 2y plus 3 quantity squared, or 2y plus 3, 2y plus 3. In the denominator, you've got a difference of perfect squares, and so in this case, it would be 2y plus 3, 2y minus 3. So since we have a 2y plus 3 in both the top and the bottom, those can simplify to be 1, and we are left with a 2y plus 3 over a 2y minus 3. Can this be reduced any further? Think about it for a second. No, this cannot be reduced any further. I don't want to see anybody trying to cancel out the 2y's and the 3's. It doesn't work. For one thing, you end up with a plus over a minus, which doesn't make any sense. And for second, like I said, you can't cancel here because if you think about these order of operations, the division bar is a grouping symbol, which is technically the P or the parentheses in the order of operations, and that comes first. Addition and subtraction come towards the end. So we have these two things grouped together, and they aren't the exact same thing because one is plus and one is minus. So we cannot simplify any further. This is the final answer. With regards to that, sometimes we have a negative sign issue, and we talked about this briefly. If, for instance, we want to distribute or factor out a negative sign depending on what we need to do, then we need to be careful with it. We can either distribute it to the numerator. So if, for instance, we had this a plus b minus c up top, then if we wanted to, we could distribute the negative up top and make sure that we have it in parentheses because we need to distribute that negative to everything on top. So it would become negative a, negative b, and positive c because that negative would get distributed to each piece inside. Likewise, we could also distribute it to the bottom. And again, we would need to make sure that we put this in parentheses. We put this in parentheses because we need to distribute that negative to each piece. So if we distribute the negative here, we would end up with a negative d and a positive 3. And to just kind of put those in common order, we would switch the order here and end up with 3 minus d so that we would have the positive first. And this is more often the thing that we are going to be doing, is looking at how we can switch the order here with two terms. So anytime you've got, for instance, a 3 minus d and a d minus 3, which look very similar, we can make them the same by factoring out a negative 1. So let's try a few examples. Example 44. We want to reduce this to lowest terms. First thing we need to do is factor the numerator and denominator. If you look at the numerator, in common they have a 5 and you are left with a 3x minus 5. In the denominator they have in common a 10 and you are left with a 5 minus 3x. Now the 5 and the 10 will simplify to be 1/2. So you're left with a 3x minus 5 over 2 times 5 minus 3x. So this is one of those cases where you get the same numbers, just in opposite order with the subtraction, and we want to factor out a negative 1 from either the top or the bottom. It doesn't matter which. Since the numerator doesn't have as much, I'll factor it out of the numerator. So when I factor out a negative 1 from the top, I'm left with negative 3x plus 5 because I just changed both of those signs. Denominator stays the same. Now I rewrite them to put the positive piece first. So then it would be 5 minus 3x. And then we still have our 2 times 5 minus 3x in the denominator. Now we have the same term, 5 minus 3x, 5 minus 3x, and we are left with a fraction of negative 1/2. So I know that seems a little tricky. Go ahead and pause the video or rewind the video if you need to see that again. We're going to do another example, but I want to make sure that you can understand that what we're doing is factoring out a negative 1 so that we can get the same term and simplify properly. So if we look at example 45, again, we're going to factor the numerator. This case is a difference of perfect squares. So we get y minus x, y plus x. And when it comes to addition, we don't have to factor out that negative because addition is commutative. We can put it in either order. Subtraction is not, because that negative needs to go along with the term it's connected to, the term that it's in front of. So the denominator here factors to be x minus y, because factors of 1 that add to be negative 2 are negative 1 and negative 1. So again, you look here, you've got y minus x over x minus y. We want them to be the same, so we are going to factor out a negative 1 from this term to make it negative y plus x. And we still have our y plus x term. And we still have our denominator exactly the same. Negative 1. Now if we switch the order here to put the positive 1 first, we get x minus y. Still have our y plus x, and we still have our denominator. Now we have like terms. Now we have x minus y, which can divide to be 1. And we are left with our negative 1 up top, our y plus x up top, and our x minus y on the bottom. And again, we cannot simplify it all here. This top one has a plus, the bottom one has a minus, and so that would not work. You can distribute the minus, but again, they both end up being negative. You end up with a negative y and a negative x. I'm going to try one more example here with you, and then I want you to try an example. So this next example, we have 6x squared plus 19x plus 10, and I know some of you are right off the bat tempted to cancel those 6x squareds. We cannot do that because things are not factored. We can only cancel factors. So if you look at the 6x squared plus 19x plus 10, now that is a good example of when we should try to use the AC method. You can try guess and check if you want to. I'm going to use the AC method. So I'm going to take 6 times 10, which is 60. So now I have my table that says I need to multiply to be 60 and add to be 19. So 1 and 60 isn't going to work. 2 and 30 isn't going to work. 3 and 20 isn't going to work, but we're getting close. 4 and 15. 4 and 15 do add up to be 19, so we are good there. So this ends up being, and I'm going to write this down, 6x squared plus 4x plus 15x plus 10. We can also do the AC method with the denominator. In that case, we have 6 times 6, which is 36. So we need factors that multiply to be 36 and subtract to be 5. Well, 1 and 36 is not going to work. 2 and 18 is not going to work. 3 and 12 is not going to work. 4 and 9 is going to work. In that case, we would want 4 and negative 9. And sorry, this should have been a negative 36 to begin with. So multiply to be negative 36, add to be negative 5. 4 and negative 9 will give us that. So we end up with a 6x squared plus 4x minus 9x minus 6. And again, don't try to cancel here. We need to factor first. So if you look at the first two terms here, we end up with in common a 2x. We are left with a 3x plus 2. If you look at the second two terms, you factor out a plus 5. And you are left with a 3x plus 2. So far, so good. They're in common. I'm going to just kind of go down here to finish this step. 3x plus 2 is our common piece, and you're left with 2x plus 5. Like I said, you could have done guess and check. That's fine. I chose to review the AC method. So if we look at the denominator here, we have, again, in common a 2x. And we are left with 3x plus 2. And if you look at the second two, notice they are both negative, so I'm going to factor that out. Negative 3, and I'm left with 3x plus 2. So our denominator ends up being 3x plus 2, the common factor, and 2x minus 3 as the remaining pieces. So again, 3x plus 2 are the like terms. Are the same terms, so we divide it by itself to get 1, and we are left with 2x plus 5 over 2x minus 3. And that is our final answer. At this point, pause the video and try the next example. Then resume the video to check your answer. Be careful, this one will need to be use that negative trick that we talked about up above to simplify. So for this example, if you went through and did either the AC method or guess and check, you should have ended up with the numerator being 5 plus x times the quantity 6 minus 5x, and the denominator being 5x minus 6 and x plus 4. Now if you notice here, 5x minus 6 and 6 minus 5x are very similar, so we're going to take a negative out of the top here. If we do that, we've got negative 1. The 5 plus x stays the same, and this becomes negative 6 plus 5x. Denominator stays the same, 5x minus 6, x plus 4. Almost done. -1 stays out front, 5 plus x stays the same. We rewrite these in order, so this is 5x minus 6. Denominator ends up being 5x minus 6 times the quantity x plus 4. So in this case, the 5x minus 6 can now simplify to be 1, and you're left with a -1, which you can just write out front if you prefer. And you have 5 plus x on the top and x plus 4 in the denominator. And that is the simplified version. You can't simplify it any further. So this concludes section 5.4. At this point, go on and do your homework for this section and then check out the video for 5.5.